Okay, so today we are going to discuss linear equations. Before we talk about how to solve them, I want to make sure that we review what a linear equation looks like. Linear equations, we talked about there are two different requirements. What are they for an equation to be linear? Right, so that's the first one, all coefficients are in terms of x. And we're talking about ordinary linear equations. Okay? And the rest? Or what's the second requirement for an equation to be linear?
All derivatives of y to the first power.
Correct. So y and all of its derivatives are to the first power. So the general equation for, or the general form for an equation that's linear is the following. That is not what we will be solving. We are going to specifically today look at first order linear equations. So in the case where you have n is 1, first order, the equation is a1 of x dy dx okay, a1 and a0, those are coefficients in terms of x. Generally, what you're going to do is you're going to divide by the coefficient in front of dy dx. So you'll get dy dx plus a0 divided by a1. I'm just going to change that to a new constant. Generally, it's called p of x. G of x divided by a1 of x is another function of x. So we'll call that f of x. This is called standard form of a linear equation. The big thing to remember with standard form is that the coefficient of dy dx is 1. So anytime that you're solving a linear equation, put it in standard form before you actually solve it. Today, we are going to look for a solution, but we do have a few assumptions that we'll be working under. First assumption that we are working under is that a solution does exist. Anytime we've found a solution, we've talked about the interval on which the solution exists. We will be looking on some interval on which p of x and f of x are continuous. Okay, so I'm going to write the equation again that we're looking at. Okay. I'm going to write us out a list of steps for how to solve this, and then we'll look at some examples. First step, you're going to write your equation in standard form. Second step, you are going to find mu of x. here's what mu of x is. E to the power integral of p of x dx. It's called an integrating factor. After you have that, you will multiply both sides of the equation by mu of x. The left-hand side of the equation is going to be the derivative of the product of mu of x and y. So the left side, you'll have mu of x times y. It'll be the derivative of that. Lastly, you'll end up integrating both sides. Okay. So we'll do an example, and this should get a little bit clearer. So we have x dy dx subtract y equals x to the fourth. Okay, so first thing to ask ourselves, is this linear? Yes. All coefficients are in terms of x. Y and its derivative are to the first power. If I wanted to solve this by separation, is this equation separable? No, this is not separable. So linear is the only method we have right now. First thing that we are going to do is we are going to put this in standard form, which means we need to divide by the coefficient of dy dx. So we get dy dx minus 1 over x times y. So remember, for standard form, we have p of x times y. So if you want to put those together, that's fine. It's just going to be a little bit easier if you make it this way. Equals x to the third. Next, we need to find our integrating factor. So it'll be e to the integral of p of x dx. P of x is the coefficient on y, so that negative 1 over x dx. So this is e to the negative natural log of x. Can I simplify that at all? Yes. What does it become? 1 over x. Okay, so then we are going to multiply the entire equation by 1 over x. So we get 1 over x dy dx minus 1 over x squared y equals x squared. The left side should be the derivative of the integrating factor times y. Now, let's verify that. Is that the case? I would get 1 over x dy dx. Derivative of 1 over x is negative 1 over x squared times y. So that works. So then what you're going to do is you'll integrate on both sides. Left side, you're just left with 1 over x times y. Right side, you're left with 1/3 x cubed plus c. Okay, cool. Multiply everything by x. So we get 1/3 x to the fourth plus c x. Okay, did we get the gist? think so? Okay. Here's your next example. We have cosine of x times y prime plus sine of x times y equals 5x. Okay, all the ones I'm going to give you today are going to be linear. It's a good thing to just double check though. Make sure you know why it's linear. All the coefficients are in terms of x, y and its derivative are to the first power. So yes, this is linear. First thing that we need to do is put this in standard form. You're dividing by that cosine of x. So we get y prime plus tangent of x times y equals 5x over cosine of x. Next thing, we're going to find our integrating factor. So it'll be e to the integral of tangent of x dx. How do I integrate tangent of x? I guess, like theoretically, if you wanted to do integration by parts, sure. How do we integrate tangent? Okay, let's try that and see if that's helpful. Is that helpful? Okay, so if you make your u cosine x, your du would be negative sine x dx. So this is e to the power negative natural log cosine x, which I'm going to express as e to the natural log of secant of x. Which will be secant x. Okay, so again, multiply both sides by secant x. Okay, left side should be the product of the integrating factor and y, the derivative of that. Again, make sure that's the case, because that tells you that you found the correct integrating factor. Derivative of y is y prime, so we get secant times y prime. Derivative of secant x is secant x tangent x times y, so that checks out. Now we're left to integrate on both sides. Left side, we get secant of x times y. What do I do on the right side? How do I integrate that? Huh? Okay, so for tabular, there's two things that has to be true. Do you have a term that when you differentiate it, you're going to get to 0? Yes, what is that? 5x. Whatever's left, do you know how to integrate that? Can you integrate secant squared? Yeah, okay, so yes, we're going to do tabular. So we have the 5x, take the derivative of that. Secant squared of x. Integrate that, you get tangent x. Integrating tangent x, we already did that. You know that you're going to get negative natural log of cosine x, or natural log of secant x, either one. So add, subtract. So we get 5x tangent x, bless you, plus 5 natural log of cosine x, plus c. Last thing, get it an implicit solution or explicit. Divide by secant x or multiply by cosine x. We get y is equal to 5x sine of x plus 5 cosine x natural log of cosine x plus c times cosine of x. Okay. Questions on linear before you guys try one? No? Great. Do you feel confident that you can attempt one? Yes? Good. This one is going to be an initial value problem, so you're going to have to find c. We get x dy, add xy plus 2y minus 2e to the negative x dx is all equal to 0. The initial condition is that y of 1 equals 0. Okay, this one's for you. Good luck. Start by putting it in standard form. Once you have it in standard form, can you check with the person next to you to make sure you guys agree? we doing? Do we have an integrating factor? Do we have mu? Not yet. When you are ready, here's the integrating factor you should have gotten. Will we be ready to talk in another minute or two? Okay. Where did we get stuck? Well, let me rephrase that. Did we get the correct standard form? Okay, so that part was okay for most of us, it seems. This is your integrating factor. The left side of the equation then, going back to here, will be x squared e to the x times y, the derivative of that product. Right side, you get 2e to the negative x over x multiplied by x squared e to the x. So that ends up being 2x, I think. Integrate both of these, you get x squared e to the x times y is equal to x squared plus c. Our y then will end up being e to the negative x plus c over x squared e to the x. How many people got that? Ooh, okay. Did I not give us enough time, or did we make a mistake somewhere? More time, okay. Initial condition, y of 1 equals 0. If you plug that in, you get c to be negative 1. I'm fairly confident you guys can find that yourselves. Is that true? Okay, so your particular solution is e to the negative x minus 1 over x squared e to the x. Okay, I know I didn't give us enough time. Did we get the general idea though? Okay, there's one other example we need to do that's a little bit different, and then there's one other thing we need to talk about here. If we take x to infinity, What happens to the first term? Goes to 0. What happens to the second term? Also goes to 0. Okay, anytime you take x to infinity and a term goes to 0, that term is called a transient term. So in this case, both terms are transient. In your homework, you're going to be solving the differential equations, and sometimes you'll be asked which term is transient. Any term that goes to 0 when x goes to infinity is called a transient term. Okay. Ready for last example? Yeah? Okay. Last example, we are going to solve dy dx plus y is equal to f of x with the initial condition y of 0 equals 0, where f of x is a piecewise function. F of x is either equal to 1 or 0. It's 1 when x is between 0 and 1. And it's 0 when x is greater than 1. Okay, here's the bad news. You're going to have to solve two different differential equations. So you have to solve the differential equation on the interval 0 to 1, and then on the interval 1 to infinity. So thankfully f of x is nothing too tough, but we are going to have to solve this twice. Okay, so first, 0 to 1. We get dy dx plus y is equal to 1. This is linear, we know that. If I wanted to, is this separable? So could I solve this using separation? Yeah, you definitely could. Subtract y, divide by that. You'll get dy over 1 minus y equals dx. We're going to do linear just because that's what we're doing in this section. Already in standard form, find your integrating factor. It'll be e to the integral of 1 dx, which is just e to the x. Left side, we get e to the x dy dx plus e to the x times y equals e to the x. Left side, if we do everything correctly, should be the derivative of the product e to the x times y. Bless you. Integrate, we get e to the x multiplied by y is equal to e to the x plus c. Our y then is 1 plus c e to the negative x. I'm actually going to call this c1 because when we solve the other equation, we're going to get another c. We're not finished yet. We still have that initial condition. So we get 0 equals 1 plus c1, so c1 equals negative 1. Our solution then is y equals 1 minus e to the negative x. Okay, that's the first solution. Again, we have to solve now on the interval 1 to infinity. This is where f of x is equal to 0, so we get dy dx plus y is equal to 0. This is linear, it's also separable. Again, we're going to use linear here. Now, don't do extra work. Our integrating factor is exactly the same. Integrating factor doesn't change. So this left side, again, will become e to the x times y, that derivative. This time is equal to 0. So integrate, we get e to the x times y is equal to c2. Our y then is equal to c2 e to the negative x. Okay, we need to be very careful here. You cannot find c2. You do not get to use the initial condition again. Initial condition is when x is 0. In this case, we're looking at x is greater than 1. We cannot find c2. Okay, so your solution then is going to be a piecewise. It'll be 1 minus e to the negative x when x is between 0 and 1. And it'll be c2 e to the negative x when x is greater than 1. Okay, there is one possible way to find C2. If we say we want our solution to be continuous everywhere, we can find C2. So we're going to do that real quick. Bless you. If we want y to be continuous, specifically x equals 1 is the place where discontinuity could happen. So that's where we're going to look. If we want y to be continuous at x equals 1, we can use that to solve for C2. Plug in x equals 1, we get 1 minus e to the negative first. That has to be equal to C2 e to the negative first. So we get C2 then is equal to 1 minus e to the negative first over e to the negative first, which ends up being e minus 1. This case, our solution is 1 minus e to the negative x, and then e minus 1 e to the negative x. Again, though, that's only if we mandate that the solution has to be continuous everywhere. Solution continuous everywhere, then you can solve for C2. If we don't say that, you can't solve for C2.